Hello guys, today we're doing question 35 of LeetCode, search insert position. This is an easy question. Question is, given a sorted array of distinct integers and a target value, return the index if the target is found. If not, return the index where it would be if it were inserted in order. You must write an algorithm with O log n runtime complexity. So this tells us it has to be binary search. And example 1, the input nums is 1, 3, 5, 6, target is 5. Is 5 in the array? Yes, it's an index of 2, so return 2. Example 2, the nums array is 1, 3, 5, 6, target is 2. Is 2 in the array? No. If it has to be inserted, it will be inserted after 1 and in between 3 in order, so that'll be index position of 1, as you can see here. Output 1. Example 3, nums is 1, 3, 5, 6, target is 7, output is 4. Because it's the biggest number it's bigger than every number in the array, so we insert it at the end, which is of index position of 4. So again, the way we do this is through binary search, and we compare the mid value to the target. If it's a target, return it. I will compare to the elements surrounding it. Else we arrange the start and end. Let me show you how we do it. Okay, so here we have our array. Here's our target, and to do binary search we obviously need a start, an end, and a mid value. The start and value is always 0, and the end value is the array length minus 1, so it's 3. To get the mid value, we add them, divide them by 2, and round it down. So 0 plus 3 divided by 2 is 1. This 1.5, but round it down is 1, so mid is 1. So we iterate this while start is smaller than or equal to end. So we check for the mid value 1, 3. We check, is 3 equal to target? No, it's not. Then we check, is 3 bigger than target? And is mid minus 1 smaller than target or out of bounds? The reason being is if the current mid value is bigger, so say target is 2, and we know that 3 is bigger and 1 is smaller, then we know we'd have to insert it at this value here, but it's not. So we proceed. Now we check if target is bigger than nums mid. If it is, then we increment start to mid plus 1. So now start is equal to 2. And now start plus end is 5. 5 divided by 2 is 2.5. And rounding that down is 2. So now mid is equal to 2. So we're at 5. Is 5 equal to target? Yes. So we return 5. That's our solution. Now let's use another example. So let's use the example of, let's keep that the same, 3 and 1. Let's use the example of target being 2, so we have to insert it. So again, mid is 1, we check. Is 1 equal to target? No. Is 1 bigger than target? Is mid bigger than target? 3 is bigger than 2, so yes, that passes. Then we're checking if mid minus 1, so 0. Is that out of bounds? No. But is mid minus 1 smaller? Yes. So we know that as it is smaller than mid, as target smaller than mid, but bigger than 1, it has to be inserted in between. And to insert it in between, it means it has to be inserted at index of 1. So we return mid minus 1. Sorry, we return mid. So we return 1, as that will be the insert position. Now let's look at a final example. Let's say target is 7, as in the final example. Now, in this case, as we complete the whole while loop and start becomes bigger than end, we then return the array length as we know that it's bigger. So let's say we're at 3. Now, is nums equal to 3? Is target equal to 3? No. Is 5 bigger than 3? Is 5 bigger than target? No. Sorry, is 3 bigger than target? We check the current value. Is 3 bigger than target? No. Is 1 smaller than target? No. So we know that 7 is bigger. So we set start as a mid plus 1. So again, start is now 2. Now 2 plus 3 is equal to 5. 5 divided by 2 is 2.5. Round it down is 2. So mid is equal to 2. Now, is 5 equals target? No. Is 5 bigger than target? No. So we know that target is bigger. So we increment start by 1 again. So start is now 2 plus 1, which is 3. Now 3 plus 3 is 6. 6 divided by 2 is 3. So now we're at the final position in the array, which is 6. Is 6 equals target? No. Is 6 smaller than target? No. So we know it's bigger. So now we have to increment start again. Start is mid plus 1, which is 4. 4 is bigger than end, which means the while loop breaks. And so we know that target is bigger than the final number in the array. So we return the number's length, so the array of length plus 1, no, the array length. So since the array length is 4, we return in the position of 4, which is here, which means that we're going to add the number to the end of the array as it's bigger. First, we start by creating the start variable, which is equal to 0. Then we create an end variable, which is equal to nums.length minus 1. Length minus 1. Then we create a while loop. So while start is smaller than or equal to end, we iterate through the while loop. Here we create a mid variable. Now math.floor rounds the function down, rounds the variable down. Then we get start plus end divided by 2. So this gets our mid variable. Then we check if the current number at the middle is equal to target, then we return middle, which is the index position. Then we check if the current number at mid is bigger than target, and number at mid minus 1 is smaller than target, or number at mid minus 1 does not exist, then we know that the insert position will be mid, because it's bigger than the smallest one, bigger than the one on the left, smaller than the one on the right, so it's inserted at that position, mid, because it's in order. Then we check if the numbers at mid is a bit smaller than target. This is if these have not iterated yet. Then we know that target's on the right side of the array, so we set the start to the mid plus 1. Else, we know it's on the left side of the array, so we set the end as mid minus 1. Now, if the whole while loop is iterated and we've not found the variable or the position, we know that it's bigger than the whole array, so it'll be inserted at the end of the array. So therefore, we return nums.length as that is in the position where it would be inserted, which is the end of the array. Let's run. As you see, passes. Let's submit. Perfect. As you can see, it's the fastest time complexity. It's time complexity of O log n. This is O log n because we searched the array in halves. So for example, you can see it's 100%. For example, if we know we search get a middle value, which would be 3. We either search the left side of the array, 3 and 1, or the right side of the array, 5 and 6. And then we search in half again, 6 or 5. Rather than searching 1, 2, 3, 4 times, we search 2 times. Thanks for watching.